It's time for another amazing chemistry video with Mr. Stapleton. Proudly sponsored by Finding a Nice Coffee.
Hi guys, welcome to this next video, which is going to be all about oxidation of alcohols today. Okay, so hopefully you know a little bit about alcohols already. Okay, and when we're talking about alcohols, we're talking about something that has the hydroxyl functional group. Okay, so it's something that has the OH on it like that. All right, so it's got a hydrogen attached to an electronegative oxygen. Okay, and this is quite a reactive site. There's lots of different things we can do with it. Now, there's three different types of alcohols that you can have. Okay, there's what we call a primary, a secondary, and a tertiary alcohol. Okay, the primary, secondary, tertiary is determined by how many carbon atoms you have attached to the carbon that has the hydroxyl group. Okay, so a primary alcohol will look something a bit like this. You've got your carbon with your OH there, and then you've got your other bonds coming off your carbon, and there's no other carbon atoms attached. All right, you can see the hydroxyl is quite free like that. It's very easy to react with. A secondary alcohol is one where you have basically two carbon atoms attached to the carbon with the hydroxyl group. So this one here for the primary, I guess if we just had hydrogen, 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 that would be methanol. You could have one carbon going here for a longer chain, so you'd have butane 1-ol, octane 1-ol, for example. Okay, but the point is that you've got this hydroxyl group, which is generally on the end of a chain, and it's very, very accessible. A secondary alcohol tends to have the alcohol group in the middle of the chain. So what you've got is your carbon atom that has the hydroxyl group on it, and then you've got a carbon atom that way, and then you might have another carbon atom that way. Okay, so you've got two carbons on there. I'll make that a little bit bigger. So you've got two carbon atoms on there. That's a secondary alcohol. What you're starting to introduce is this concept of steric hindrance. Now, steric hindrance is where it's hard for a functional group to react because you've got other groups around it which prevent it from getting reacted with. So if we want to have a reaction here, all right, of our alcohol group, the OH, we actually need to be able to meet or find that carbon that the OH is bonded to. So if we want to react here, we need to actually react with the carbon in here. That's where we form new bonds and break off the carbon-oxygen bond. So we need to be able to get to that one. Here with two carbons on it, you can see that it's getting a little bit clumped together. Okay, so it's a little bit hard for it to reach. A tertiary alcohol, all right, has the carbon here, and then you've got a carbon atom, carbon atom, carbon atom with your OH there. Okay, and so what you can see is that very clearly we've got a lot of steric hindrance around our central carbon, which makes it really difficult to react with. However, if you just had a beaker of three different alcohols, one a primary, one a secondary, one a tertiary, you wouldn't be able to tell the difference between them. They're generally all clear, colourless liquids. Okay, they have that kind of medicinal smell to them. You know, ethanol is really good at being used as an antiseptic, right? So if you've got a wound or you want to clean something, get rid of germs, you can put it in some alcohol, which is ethanol, okay, and it helps to kill it off. So you wouldn't be able to tell just by looking at them. So we need to do some chemical tests to distinguish between them, okay? Now, to do a chemical test, we use a very specific chemical. Normally what we use is something called acidified dichromate. Okay. Now, acidified dichromate uses two things. It uses normally potassium dichromate. So the dichromate is Cr2O72-, okay, which is orange in colour. And then we acidify it with some hydrogen ions, so generally some concentrated sulfuric acid, or might be dilute sulfuric acid, depending upon how much you need. Okay. And this is orange in colour. Now, this is a very strong oxidizing agent, which means it will oxidize alcohols. And each of the alcohols oxidizes in a different way. And what happens is if the dichromate undergoes reduction, so it oxidizes something else, what happens is it goes to chromium ions. Okay? And chromium ions, Cr3+, are green. Okay? So you have a half equation that occurs here. All right? Cr2O72-, all right, picks up 6 electrons, 14 hydrogen ions, and what you get is 2 lots of your green chromium ions plus 7 lots of water. Okay, And so it's a very, very clear reaction to be able to see when an alcohol has undergone oxidation, because you've got this very clear orange to green colour change as your dichromate goes to your chromium. So what I'm going to do is I'm going to show you what reactions happen, because a primary and a secondary and a tertiary all react differently with acidified dichromate, which is how we can actually tell the difference between them. Okay, so the first alcohol I'm going to look at is a primary alcohol, and I'm going to be focusing on ethanol. Right? Usually when most people think about alcohol, they think of ethanol. It is the component of alcoholic drinks. It's produced via fermentation of glucose. Okay, so what we're going to do is we're going to look at the reaction of ethanol with acidified dichromate solution. So ethanol, when it's reacted with acidified dichromate, actually goes through a two-step process, and this is normal for any primary alcohol. So first off, your ethanol, CH3CH2OH, okay? When you react that with with your acidified dichromate that we've got here, so we're going to add in acidified dichromate, which is orange. All right, so Cr2O7 2- with the acid in there. Okay. Alcohol is oxidized. Remember, dichromate is an oxidizing agent, and so one of the things that will happen is that we will start to convert this through to something that contains more oxygen. But initially what happens is the ethanol here actually converts to an aldehyde. So what we get is this, all right, which is ethanol. So first step from ethanol, oxidized with acidified dichromate solution, is to go to ethanol. Now we would see an orange to green colour change here because our dichromate would be oxidized. However, aldehydes can also be oxidized, and what happens is that this gets oxidized what's called in situ or in solution. So ethanol is oxidized to ethanol, okay, and straight away that oxidizes again, okay. And what happens is, because there's more dichromate in there, and so unless you control this reaction, you just continue to get your oxidation occurring, and you get to here, which is ethanoic acid. Now, another name for that is acetic acid, or the common name is vinegar, okay? So this is why wine bottles, when they've been left out without a cork in or the lid on or anything like that, they actually start to taste like vinegar, because what's happened is oxygen has got in from the air and it's oxidized the ethanol to acetic acid or ethanoic acid, which is vinegar, okay? But this is a continual process, and that is unique for primary alcohols, okay? So primary alcohols will oxidize with acidified dichromate to an aldehyde and then to a carboxylic acid, right? Straight away in that step. They're the only ones that do that. Now, the way you can test if you actually had a primary alcohol is at the end, what we've got is a carboxylic acid. So if you react that, and one way you can do that is react that with sodium carbonate solution. If you react that with sodium carbonate solution, you'll get effervescence of CO2 gas. So that's a way to test. Sometimes what you can also do is your aldehyde up here, what you can do is you can react that with Tollens reagent, which is ammoniac or silver nitrate. Now that will produce a silver mirror, which is also a test. And normally you'll have a little bit of aldehyde in there that hasn't been oxidized, so you will get a silver mirror with Tollens reagent. So it's a really easy test to see that you've actually in fact had a primary alcohol to begin with. So like I said, that's unique for primaries. I'm going to explain about what happens for secondaries. Okay, so when we're talking about secondary alcohols and the oxidation that they undergo, it's a little bit different to the primary alcohols. In your primary alcohols, your OH group, your hydroxyl group, is at the end of the chain. Okay, so it's a little bit easier to get to and to react with. Here, with the secondary alcohol, your OH group is in the middle of the chain. Now this is propan-2-ol, okay, 3 carbon atoms. Second carbon atom has a hydroxyl group, so propan-2-ol, it's an alcohol, and it's a secondary one. So when we react this with acidified dichromate, we still get a colour change, all right? So we've got propan-2-ol here, okay? And what we're going to do is we're going to react that, all right, with our acidified dichromate again, which is orange. Let's try and get the colours right for you. So with your acidified dichromate again. But this time, what happens is that we get a new structure, a new functional group. So the central carbon atom here, which had the OH group on it, actually gets converted into a ketone. Okay, so now what we've actually formed is propanone. Okay, so secondary alcohols, when they oxidize, they go to ketones. Primary alcohol went first to an aldehyde, then a carboxylic acid, but the secondary goes to a ketone. All right. Now, this has quite a sweet smell to it. They're often used in perfumes, fragrances, things like that as well. But quite clearly, these won't react with the sodium carbonate or with the Tollens reagent that we looked at for primary alcohol. So if you get a colour change from orange to green, all right, and you're not sure if it's a primary or secondary alcohol, you test it in that second way with the Tollens reagent or sodium bicarbonate or carbonate. If you get a reaction, it's a primary. If you don't get a reaction and you just get the orange to green colour change, then it's your secondary alcohol. Tertiary alcohols are really simple. Tertiary alcohols, because of that steric hindrance around that central carbon atom, don't react. Okay, so if you add in acidified dichromate solution and you heat it up, it's going to stay orange. There's no green colour at all. So tertiary alcohols don't react. Okay, so there's a really simple little flow chart which I'll put up now. All right, which will explain to you the processes that you go through. So add your acidified dichromate to each of them. Okay, your primary alcohol will first go to an aldehyde, then a carboxylic acid. You can test for the presence of the aldehyde using Tollens reagent, it will go silver, or you can test for the presence of the carboxylic acid by adding sodium carbonate or sodium bicarbonate in there, and you get effervescence. All right. If you get an orange to green colour change and there's no further reaction with any of those chemicals, that means you've got a secondary alcohol, all right, and you've formed a ketone. If there's no colour change from orange to green, okay, that means you've got a tertiary alcohol, and it's easy to identify. So hopefully this has helped you understand a little bit more about how you chemically test for a different alcohol. They love to ask questions about this in the exams, so if you need to, go back and have a look. All right, and as always, if you've got any questions, just ask. Thanks, guys.